Okay, let's unpack this. You're writing some code, right? And inevitably, it needs something else to work. Maybe a database or some external API.
Yeah, exactly. It almost always depends on something. Another service, maybe even just a complicated function somewhere else in the code base.
And that's the snag when you try to test just your piece. How do you do that reliably if that database is slow today or the API is down?
You hit the nail on the head. If your test fails because of some external hiccup, you haven't really learned anything about your code's correctness. It's frustrating and, well, not very useful.
Right. So the solution we're digging into here is using what are called test doubles. You often hear terms like mocks, stubs, spies thrown around.
There are all types of test doubles.
Hmm.
Fundamentally, they're stand-ins, fakes, if you like. You use them to replace those real dependencies during your tests.
And the why seems crucial here. Why go to the trouble of creating these fakes? The first big reason seems to be isolation.
Absolutely number one, isolation. You swap out the real dependency for a double. This means your test runs against only the code you intended to test your unit.
So if the test fails,
If the test fails, you're much, much more confident the bug is actually in the code you're testing, not because, the network connection decided to take a break.
it pinpoints the problem. Makes sense, like testing just the engine, not the whole car at once on a bumpy road.
Exactly. And the second big why is control. Real dependencies can be unpredictable.
Yeah, APIs change error formats. Databases might have slightly different data loaded today versus yesterday.
Precisely. With a test double, you dictate its behavior completely. You tell it exactly what data to return or exactly what error to throw under specific conditions.
So no more flaky tests that pass sometimes and fail others for no obvious reason.
That's the goal. Predictable dependencies lead to reliable, deterministic tests. You trust your test results more.
Okay, isolation and control. And the third key benefit that often gets mentioned is speed, right?
Oh, speed is huge. Think about it. Calling a real database, making a network request to an API, that takes time. Milliseconds, maybe seconds.
Which adds up fast if you have hundreds or thousands of tests.
It really does. Replacing those slow operations with a test double that just returns a predefined value instantly. It can slash your test execution time dramatically.
Seconds instead of minutes, maybe even hours for really large suites. That means faster feedback for developers.
Definitely. Faster feedback loops mean you catch issues earlier, you iterate faster. It's a big productivity win.
So to recap, isolation lets you focus the test, control makes it reliable, and speed makes it practical. These are the core reasons for using doubles.
That's pretty much it. They allow you to create this sort of sterile controlled environment specifically for verifying your code's logic.
Now, how do we actually do this? You mentioned tools like Jest, which is super common in the JavaScript world. It seems to have specific ways to create these doubles.
Yeah, Jest provides several handy functions. The most basic one is probably jest.fn. It just gives you a blank mock function.
A blank slate. What can you do with it?
You can tell it what value it should return using .mock return value. Or, if you need more complex logic, you can give it a whole new implementation with .mock implementation.
Ah, okay. So you can just make it return true or make it simulate some complex calculation.
Exactly. And crucially, afterwards, you can check if it was called, how many times, and what arguments it received. It's great for simulating simple functions or checking callbacks.
We often call that stubbing, right? Providing
Right.
canned answers.
Yeah, jest.fn is often used for stubbing. Then you have jest.spyon. That's a bit different.
How so?
Spyon wraps an existing method on a real object. So the original method is still there and can even be called, but the spy watches it.
Watches it. Like it records if it was called?
Yep. It records calls, arguments, just like jest.fn.
Yeah.
But you can also use it to temporarily override the original method's behavior for a test, maybe force it to return a specific value without permanently changing the object.
Okay, so spy on is more for when you want to observe or slightly tweak a real object's method, not replace it entirely. Verifying interactions, maybe.
Exactly. You're checking how your code interacts with that real dependency, perhaps just controlling one small part of it for the test scenario. We often associate this more with mocking or spying.
Got it. Stubbing with just.fn, spying or mocking interactions with just.spyon. What about bigger dependencies, like an entire module?
Right. Sometimes you need to replace a whole chunk of functionality, maybe an entire API client library. That's where jest.mock comes in.
Mocking a whole module, how does that work?
You tell Jest the path to the module, and it automatically replaces all its exports with mock functions. It's really powerful for swapping out entire layers of your application for testing purposes.
Wow. Okay, so it handles replacing everything exported from that file automatically.
Pretty much. It gives you a clean slate for that entire dependency, letting you define the behavior of all its parts as needed for your test.
So Just gives you a range of tools, jest.fn for basic function stubs, jest.spyon for observing or tweaking real methods, and jest.mock for replacing entire modules, different tools for different levels of isolation.
Exactly. It's about choosing the right technique depending on what you need to achieve in your test. Whether it's just providing data, checking if a function was called, or completely isolating your unit from a complex dependency.
Understanding and using these effectively feels fundamental. It's key to writing tests that are actually useful, fast, reliable, and pinpointing bugs in your code.
Couldn't agree more.
Or
Mastering these techniques is a big step towards building more robust and maintainable software. They really empower you as a developer.
Definitely. So, as you get comfortable using these doubles to replace dependencies during testing, here's something to maybe chew on. How might this practice influence how you design your code in the first place?
Hmm.
If you know you'll need to easily swap out dependencies for tests, does that change how you think about structuring your code and defining the boundaries between different parts from the very beginning?
Yeah.
Something to consider.